Okay, so welcome back and let's keep going. We're currently on question number 1 from exam 2 of the 2016 fall semester. And it says, which statement is true about the bonds in the species oxygen? Oxygen was one less electron, oxygen was one more electron, and oxygen was two more electrons. So for conventional purpose, I already jotted down the exact molecular orbit over here. So it should be easier to see. And let me just specify the antibonding orbits with the asterisk. And oxygen is just a regular, like a 6-valence electron species. So I would say the molecular orbit would look like something like this. And it should be 12, yes. And the definition of the bond order is, so bond order is equals to the numbers of electrons in bonding orbit minus the number of electrons in antibonding orbit divided by 2. And I should probably do a better divided by 2. Oh, I'm still using the huge number of electrons divided by 2. And the number of electrons in bonding orbit, perhaps I should just do it in color code. So what it means by the numbers of electrons in, it's been flying around a lot lately. What it means by the numbers of electrons in bonding orbit is the orbit without, oh lord, we'll have that down. Cool. Let's just draw it back real quick. Cool. So what it means by is that the ones without the asterisks. So these are the bonding orbits, and the anti-bonding orbits are, I should probably do it just to say, and the anti-bonding orbits are the orbit with the asterisk on top of them. So are these ones. So the orange ones are all the anti-bonding orbits. And the blue ones are all the bonding orbits. So as you can see, for a regular oxygen, it's going to be, I would say, I think I'm missing a line over here. It's 1, 2, 3, 4, 5, 6, 7, 8. It's 8 minus, come on, minus 6 divided by 2, and that is 1. 8 minus 4, I'm sorry. 8 minus 8 minus 4 divided by 2, which equals to 2. So that's a 2 bond order for oxygen, and for oxygen plus, it's just like removing 1 electron from the origin of oxygen, and let's just remove this one over here real quick. This is really touchy, and let's just try to redraw everything back real quick. Why the colors been changing frequently? Oh Boy, come on. The color's been flying around. I have no idea why. It's like I have to play a piano. Meanwhile, I was drawing, and well, now I have no idea how should I recall my orange pen back. So I should change color over here, and let's do a circle around here, and hopefully it doesn't resynchronize itself. Anyways, so for oxygen plus, it's going to be so we're removing one electron, and let's do it this way. Let's do it this way, and let's do the calculations. It's going to be 8 minus 8 minus 3 divided by 2, and that equals to 2.5, I believe. So it's 2.5 for the oxygen plus, and oxygen minus it just means one more electron. So let's just add it back to become a regular oxygen molecule, and we just add one more. So this one should be I'd say it's so this is the oxygen 2 minus, and so this is going to be 8 minus 5 instead of 3 divided by 2, which is 1.5. Bond order. So it's 1.5 for oxygen negative, and for oxygen 2 negative is just adding one more electron towards the graph. So just one more electron. Then the oxygen minus, so it's going to be 8 minus 6 divided by 2, and that gives us 1. So it's 1 for the oxygen 2 minus, and therefore apparently the oxygen plus has the highest bond order, which gives us A is the correct answer. A is the correct answer. Okay, so we'll stop here.